The Hindenburg ignited in a mere 34 seconds, its colossal form reduced to ashes. Why did humanity's dream and pinnacle of technology explode in midair? On May 6, 1937, 35 lives were lost, signaling the end of the airship era. Yet, this tragedy had preventable causes. In fact, this failure stemmed from systemic causes that persist even today: technological overconfidence, political pressure, and a disregard for safety. What truly happened? In this documentary, we unravel why a seemingly perfect design became the seed of its downfall, who overlooked what, and what lessons it holds for modern society. Now, let us delve into the full story of the Queen of the Sky's collapse. The main feature also provides a detailed explanation of how the international situation at the time influenced the accident. In the 1930s, airships symbolized luxurious air travel. Zeppelin's LZ-129, commonly known as the Hindenburg, stood at its zenith. With a length of 245 meters, the size of 3 football fields, its colossal form was truly a flying hotel. It crossed the Atlantic in just 2 days. Its top speed was 135 kilometers per hour, with a passenger capacity of 72. On board, it boasted private cabins, an observation lounge, and even a smoking room. In 1936, during its inaugural year, the Hindenburg completed 10 transatlantic round trips, safely transporting over 1,000 passengers. Its safety and comfort surpassed even the most advanced aircraft of its time. For the wealthy, airship travel was the ultimate status symbol. Nazi Germany heavily utilized this colossal airship as propaganda, symbolizing national prestige. With a perfect operational record and as the pinnacle of contemporary technology, the Hindenburg promised the future of air travel. Everyone believed without a doubt that this colossal airship would continue to offer safe and luxurious air travel indefinitely. The airship's success lay in its stable flight and impressive cargo capacity. It could transport large goods and numerous passengers over long distances. Fixed-wing aircraft of the time could not match this level of payload or comfort. The technological superiority was undeniable. The Hindenburg structure consisted of a lightweight aluminum alloy framework and numerous hydrogen gas cells. These were the source of its buoyancy. Hydrogen is highly flammable but inexpensive and offers significant lift. The designers believed they had implemented stringent safety measures. Originally, the plan was to use much safer helium gas. However, the United States was the sole supplier and refused to export it to Germany. Consequently, reliance on dangerous hydrogen gas became unavoidable, driven by political and economic reasons rather than safety. Despite this, previous Zeppelin airships using hydrogen had not experienced major accidents. There was overconfidence in experience and technology. Crew training was thorough, and protocols existed to prevent accidents. Up to this point, everything appeared to be proceeding smoothly. However, the decision to use hydrogen gas was merely the tip of the iceberg. A fatal structural flaw lay hidden within the airship itself. The biggest pitfall lay in the dope, a paint-like coating that covered the hydrogen gas cells. This coating had a propensity to accumulate static electricity. Furthermore, contemporary Germany was in economic distress, leading to speculation that cheaper, flammable paint was used instead of more expensive, conductive coatings. The waterproof surface coating and the material of the internal gas cells all combined to create a dangerous mixture conducive to spark generation. During preparations for landing, the weather deteriorated into a thunderstorm. It is estimated that the airship accumulated tens of thousands of volts of static electricity. The moment the landing ropes touched the ground, this static electricity discharged, causing sparks to fly from the airship's frame. These sparks then ignited the leaking hydrogen. This chain reaction was the worst-case scenario the designers had not anticipated. They had been overconfident about the dangers of hydrogen. But here, a trap no one noticed had opened. It lay not just in technical issues, but also in the collective psychology of the entire organization. The Hindenburg was a national project, a symbol of Nazi Germany's prestige. Its success was indispensable to the regime, Therefore, even if minor risks or problems were pointed out, halting or delaying the project was never an option. Much like the Concorde effect, the enormous investment of cost, effort, and national honor had created a psychological state from which there was no return. Engineers recognized the dangers of hydrogen, but with helium unavailable, they fell into groupthink, believing there was no other choice. Even slight safety concerns were overridden by the overarching goal of the project's success. Despite strong winds and thunderstorms being forecast for landing, the operation proceeded. Adherence to the schedule was prioritized. At the time, inadequate mooring facilities for airships at the Lakehurst Naval Air Station in the United States also heightened the risks. Overconfidence among engineers, political pressure, and a lack of information sharing, numerous warning signs were overlooked and accumulated. Thus, the colossal airship, which everyone had believed to be perfectly safe, moved irrevocably towards a tragedy that could have been avoided. May 6, 1937, 7:25 p.m. Above Lakehurst Naval Air Station, the Hindenburg began its landing approach. Due to strong winds, the airship's stern was buffeted, forcing an abrupt turn. At this moment, static electricity reached abnormal levels. 7:25 and 30 seconds p.m. A hydrogen leak occurred from a gas cell in the upper port side. The instant the landing ropes touched the ground, static electricity discharged and ignited the gas. Flames spread rapidly throughout the entire airship, and its colossal metal framework erupted in fire, like matchsticks igniting. Large crowds on the ground witnessed an unbelievable sight. Cheers turned to screams, and anticipation transformed into despair. The burning airship crashed to the ground in a mere 34 seconds. Humanity's grand dream of the skies met an abrupt end. This accident claimed 35 lives and definitively marked the end of the airship era. Never again would a large hydrogen-filled airship cross the Atlantic. The Hindenburg's collapse was not merely a technical failure. It was a human-made disaster compounded by overconfidence, cost-cutting, and political agendas. Even in modern technological development, the lessons of the Hindenburg endure. It teaches us that compromising on safety will always, eventually, come at a cost. How did a project at the pinnacle of success fall into a fatal trap? Its reasons held a universal structure relevant to modern society. Technological overconfidence, political pressure, and a disregard for safety. By overlooking these, the worst air tragedy in history became inevitable. And today, are we not seeing similar decisions around us? Cost over safety? Risk for honor? The Hindenburg tragedy compels us to reevaluate the quality of our own decision-making, offering invaluable lessons to avoid future failures. Those who understand this failure versus those who don't will make different quality decisions in critical moments. This knowledge will be a shield protecting your future. If you found this video insightful, please subscribe and like. We share a new history of failure every day.
この失敗は歴史のほんの1ページ。世界にはまだ語られていない失敗が数多くあります。失敗の歴史をチャンネル登録して次の物語もぜひご覧ください。